Hey guys, this is an introduction to interval notation. 2.4 and 2.5 are interval notation and solving x when it's not an equation, it's an inequality. And then 2.6 will be absolute value. I don't know why I couldn't think of that. All right, 1 second. Okay. So using interval notation, solving linear equalities using the addition property, the multiplication properties, and solving problems that might be telling a story that you can change into an inequality. Good? Okay. An inequality, it just means you take an equation such as 2x plus 3 is 11. That's an equation because there's an equal sign. And you change the equal sign to a greater than symbol or a less than symbol. So 2x plus 3, instead of having one answer, now has many answers, right? Because it's here there's one answer. There's one thing x will be, right? And we can solve it for x. We can subtract 3 and then we can divide by 2. Here we can subtract 3 and we can divide by 2, but our answer is going to be 2x plus 3 is equal 11, subtract 3, 8. So now x is 4 for sure, right? But if it's a greater than, then we do that subtract 3. 2x is greater than 8, divided by 2. X is now greater than 4. So it's not just one number, it's not just 4, it's every number that is bigger than 4. There are infinitely many numbers that are bigger than 4, okay? So instead of an equal sign, it has one of these symbols: less than, greater than, less than or equal to, greater than or equal to, okay? Memorize those. Equations have an equal sign, inequalities have one of these 4 inequality symbols. The solution of an inequality is a value of the variable that makes the inequality a true statement. So we could say the solution to this is 5. The solution to this is 100, right? But the solution set is all the possible answers. So it's harder to write every number bigger than 4, right? What we do instead is we say it's from 4 to infinity. That's that symbol. And if we were talking about less than 4, then we would say from negative infinity up until 4. Okay? So the set is telling me every number that it is included in this answer, any number that it could be, all the solutions. Okay? That is what we mean when we use the word inequality. So how do we write inequalities? I'm going to go over this again in 2.6, sorry, 2.5. I'm going to go over this again in the next lecture, but I just want to cover this. There are 3 new ways to write interval notation, okay? There are 3 different ways to write inequalities. We have set notation. We can graph the inequality on a number line and use interval notation. We are not going to use we're not going to graph it. We're only going to graph it on the number line. We're not going to graph it on the XY axis. So what was I using? I was saying X. We're saying X is greater than 4. So I'll use X. X is less than 4, right? What would the graph of X is less than 4 look like? Well, here's 4, right? X is everything smaller than 4 forever. There's a difference between what I did here and this arrow. It's just hard to tell with a highlighter. So what I did was this symbol, like a parenthesis, okay? And then I drew an arrow just saying this line is going to continue towards negative infinity forever. So that's the graph of X is less than 4. This is what we're familiar with from earlier math classes. Here's a graph on the number line. We're becoming familiar with the number line. Here on the graph would be 3, here would be 2, right? Interval notation is a new way to write x is less than 4. Here's a way to write x is less than 4. Interval notation, I take the graph and I write it as what looks like a set of points, right? So my interval of this answer is between 4 and negative infinity. It begins at negative infinity, it goes until 4. Okay, we'll do another one. What about if x is greater than 4, right? What would that graph look like? Here's 4, here's 5. 5 is bigger than 4, greater than is always to the right. Greater than is always to the right. So here, my parentheses was opening towards the negative infinity. Now my parentheses is going to open towards positive infinity, and the arrow is going to go towards positive infinity. My line continues forever, okay? This was negative infinity. This way is positive infinity. This way is positive infinity. This way is negative infinity. A number line keeps going forever, never stops, okay? So for my interval notation, I don't start at negative infinity. I actually started at 4, and I go until infinity. Ending at infinity. A bit vague, but there are 2 more we're going to cover. What if x is less than or equal to 4? How does that change things? Less than 4 means it cannot be 4, right? If a number is less than 4, it cannot be 4, right? But less than or equal to 4, the whole equal to thing means that this is okay, right? If this is okay, then I want to denote that when I graph it. So I'm going to graph it with a different symbol than just the parentheses. I'm going to use a bracket to include the 4 in the bracket. When I use my interval notation, I'm still starting at negative infinity. I'm still ending at 4, but to show that 4 is included in my answer, I'm going to use a bracket. Good? Same thing for x is greater than or equal to 4. Again, it's okay if our answer is 4, whereas in these first 2 examples, 4 is not in our solution set. Good? So x is greater than or equal to 4. Here's 4. It's going to be going above 4 forever. It's going to include 4. So now I start at 4, I include 4, and I go towards infinity. Notice that infinity will never have a bracket. It will only ever have parentheses. Infinity isn't a number that we can include or exclude. It's just forever, right? Forever negative, forever positive, forever in both directions. So it gets parentheses, it never gets included. So badly on both sides of that. This is from negative infinity to positive infinity. The arrows go on forever. And I would write it as x is all real numbers. Okay? Or x is a real number, you can also say. So this is what we're talking about. These are the 3 ways to write it: set notation, graph, and interval notation. Something else about set notation. We're familiar with x is less than 4, x is greater than 4, x is less than or equal to 4, x is greater than or equal to 4. It might also appear this way: x such that x is less than 4, x such that x is greater than 4, x such that x is less than or equal to 4, x such that x is greater than or equal to 4, and because it's a set, we do a different kind of bracket. So that's a bracket, bracket, bracket. We do a different kind of bracket to denote that this is a group. So we fancy it up a bit sometimes, but it's still that same, all of the math is right here. Okay? All right, so that's interval notation. Inequalities, compound inequalities we will talk about in the next lesson. So graph you set on a number line and write in interval notation. If you wrote down this with me, I would just have it near you. Good, little answer key. X such that x is greater than or equal to 2. As long as you have a 2 on your number line, you don't really need anything else necessarily, all right? Greater than or equal to 2. So if it's greater than, it's going to go this way. Yeah? And if your variable is on the left, that also tells you which way your arrow goes, right? That's an arrow pointing forever in positive infinity. That's going to go towards negative infinity. That's a less than symbol. Less than. Less than. Only if your variable is on the left, though. This one you'd have to flip it around and say that 0.5 is less than x is the same as x is greater than 0.5. You're welcome to just switch them around if you like. So this is x is greater than or equal to 2. The arrow is going that way because the greater than symbol I look at as an arrow. Equal to means it gets the bracket. So it includes the 2, so we need to bracket the 2, okay? And then interval notation, I just take what I already wrote. So I wrote on the number line a bracket. I started my bracket at 2, and my line goes forever. Forever means infinity. Infinity always gets a parenthesis. Good. So that was A. I know I'm not going to have room to fit them all right next to right where I want them to be. B, x is less than negative 1. Here's my number line. I started with negative 1 right in the middle because that's convenient. Less than negative 1. Again, the less than symbol looks to me like an arrow pointing in the negative direction. So it's going that way. It does not include negative 1, so you just do the parentheses. Done. X is all values less than negative 1. So for my interval notation, I'm going to start at negative infinity. You're always reading from left to right. So it starts at negative infinity. It starts with an arrow towards negative infinity. It stops at negative 1. And it stops with a parentheses, not a bracket. Done. So there's B. C is a compound inequality. We will talk about those more next time. X, I'm going to skip over this part. X is less than or equal to 3. X is less than or equal to 3. So the equal to means, well, less than means I'm going this way from my 3. Equal to means it's going to be a bracket, not a parentheses. You cannot see that one at all. It's going to be a bracket, not a parentheses. It's going this way because it's less than. And the compound part is x is greater than 0.5. So down here, I'm going to make a 0.5. X is greater than 0.5, or 0.5 is less than x. Again, I like to make it look like the x is always on, the variable is always on the left. It does not include an equal sign, so it's going to look like that. And the arrow's going that way. But these arrows are going to what? Collide, maybe? And the parentheses are going to stop them. So it's saying x is from 0.5 to 3. It's going to include 3. It's not going to include 0.5. So it's going to start with parentheses at 0.5. It's going to stop at 3 with a bracket. (0.5) is less than x. X is greater than or equal to 3. X is greater than 0.5. X is less than or equal to 3. Just kind of go back, read it, make sure it still makes sense to you. To solve an inequality, clear the grouping symbols, clear the fractions, isolate the variable to the left of the inequality using opposite operations, undoing addition or subtraction first, followed by undoing multiplication or division. The only difference between an inequality and an equation when you're solving is if you multiply or divide by a negative number, you have to reverse the inequality symbol, or else it will no longer be a true statement. Okay? So, if I had 4 is less than 6, we know that's true, right? If I multiply both sides by 2, 8 is still greater than, or sorry, 8 is still less than 12, right? If I divide both sides by 2, shoot, I'm out of room. All right. I still have the 4 is less than 6. I'm going to divide both sides by 2. 2 is less than 3. Still true, right? 4 is less than 6. What if I multiply it by a -5? Right? So if I multiply by a positive, it's still true. Divide by a positive, still true. What if I multiply by a negative? 4 times a -5 is a -20. 6 times a -5 is a -30. Think about this. Is -20 still less than -30 on the number line? Here's -30. Here's -20. My less than is that way, right? Is -20 less than -30? It is not, okay? So if we involve solving with multiplying or dividing by a negative, we have to reverse the inequality symbol so that it's a true statement. So this is no longer true, right? Even if it was something simple like 4 divided by -2. So 4 is less than 6. Divide by -2, that would be a better example. 4 divided by -2 is a -2. -2 is less than 6 divided by -2 is -3. Is -2 less than -3? It is not, right? It's more than -3. So it just kind of changes things when we flip from a positive number to a negative number. So to account for that, if you divide by a negative, you flip the sign. -2, flip that sign, is greater than -3. That is still true, whereas that is not true if you don't make that switch. That's why all you need to remember is if I multiply or divide by a negative, reverse the symbol, flip the symbol, okay? Here, x minus 2 is less than 5. Add 2, add 2. X is less than 7. Good? So we wanted to find every value for which you can subtract 2 and get a number smaller than 5, right? What I'm getting is x is less than 7. I can graph that. Here's 7. X is less than 7. It doesn't include 7, so it's a big parentheses. And an arrow, right? X is less than 7. And then I would say that goes from -infinity to 7. Okay, those are my 3 ways of writing it. X such that x is less than 7. Here's my graph. Here's my interval notation. Good? Okay. And you can test it. Okay, 7, anything less than 7. 0 is less than 7, right? 0 minus 2 is negative 2. Negative 2 is less than 5. That's true, right? So you can check your answer with any number on that number line. 3x plus 4 is greater than or equal to 2x minus 6. Good? All right. So I want to move all of my variables to one side, all of my constants to the other. Again, just like when we're doing equations, it doesn't matter which side you move things to, but remember that when you multiply or divide by a negative, it's more important, or it's more like there's another step. So I would even do more to avoid getting my x's negative. So I have a 3x and a 2x. I'll subtract the 2x so that my x stays positive. 3x minus 2x is just x. Keep the 4. Subtract the 4. So now I've moved all of my constants to the right and all of my x values to the left. I have x is greater than or equal to negative 6 minus 4 is a negative 10. Good? What does that look like on the number line? Here's negative 10. X is greater than or equal to. Equal to means it's going to include negative 10, so we're going to use a bracket. So the way that I would write that interval notation is bracket negative 10 all the way to infinity. Infinity will never have a bracket, only a parentheses. Good? So what we're saying is any number greater than or equal to negative 10 can be substituted into this equation, or sorry, this inequality, and the inequality will remain true. Any number bigger than negative 10, so 0. 3 times 0 plus 4 is greater than or equal to 2 times 0 minus 6. Yeah? 4 is greater than or equal to negative 6. It's true. 1/4 x is less than or equal to 3/2. None of the rules change. We just happen to be using fractions now. Instead of in an equation, it's in an inequality. So we have 1/4 times x is less than or equal to 3/2. 3 is being divided by 2, x is being divided by 4. Do you have a least common denominator between 2 and 4? Here the denominator's 4, here the denominator's 2. If you don't understand least common denominator, just say, well, I want to get rid of this fraction. 1 is being divided by 4, multiplied by 4. Anything you do over here, make sure you do it to everything else in the problem, and that will also get you to your answer. It's okay if you don't understand least common denominator. If you do understand least common denominator, the 4 is going to be your least common denominator because I can take 4 and divide it by 2, and I can take 4 and divide it by 4. So my least common denominator is 4, or I want to get rid of this 4 in the denominator. How do I get rid of the denominator of a fraction? I multiply everything in the problem by that denominator, right? Now, the 1x is being multiplied by 4 and then divided by 4. If you multiply by 4 and then you divide by 4, the 4's cancel out. 4 times 1 divided by 4 times 4 divided by 4, they go away, okay? So then you just have 1x. Here, we're going to say 3 times 4 divided by 2. 3 times 4 is 12. 12 divided by 2. So what you can do is, I don't like this fraction, so I'm going to multiply everything by 2, right? 12 times 2 divided by 2, they cancel. 2x less than or equal to 12, divide by 2, x is equal to 6, right? So you can go one by one. I'm going to get rid of the 4 by multiplying by 4, multiplying by 4. Get rid of the 2 by multiplying by 2, by multiplying by 2. Or you can see 12 over 2, the fraction is just the same as 12 divided by 2. x is greater than or equal to 12 over 2 is the same as x is less than or equal to the number 6. Good? So that's just a quicker way to get to it. Multiply by 4 because of this one. Multiply by 2 because of this one. And you get x, ooh, sorry, I didn't use the right symbol. X is less than or equal to 6. How would I graph that? X is less than or equal to 6. Here's 6. The equal to means it's a bracket, and the less than means it's going towards negative infinity. So I would then look at my number line and say my number line starts at negative infinity and goes until 6 and has a bracket. Good. X is less than or equal to 6. The graph looks like this. It goes from negative infinity to 6. One more thing I want to note. About 1/4 x less than or equal to 3/2. This is exactly the same as x is being multiplied by 1 divided by 4. So it's the same as x over 4 less than or equal to 3/2. Okay, we can write it like this, or we can write it like this. X over 4, 3 over 2. Okay, and then when we multiply by 4, right? We just get x is equal to 3 times 4 is 12 over 2. So we get exactly back to this. So it doesn't matter if you see it like this or you see it like this. It's the exact same equality. It is equal the same amount. Example 5 is just an opportunity to use decimals, but we also get to practice finally flipping, because we're going to divide by a negative 2.3. So we're going to take 6.9 divided by negative 2.3. Oops. Negative 2.3, and we get negative 3. X over here, negative 3 over here, but because we divided by that negative, we had to flip the sign. Okay? The graph for x is greater than negative 3 is going to be, here's 3. X is greater than negative 3, so that means it's a negative 3. It starts at negative 3, goes forever in the positive direction. It does not include negative 3, so it's a parentheses. Example 6. You can, so we're going to solve for x just like we did in example 3, where we had an x on either side. Here you can either distribute the 5, or you can divide this whole side by 5 and divide this whole side by 5. I don't think 3 divided by 5 or 9 divided by 5 are very easy. I don't want to create fractions, but if it was like 20x plus 10 less than or equal to 5 times x minus 1, then if you wanted, you can just divide this side by 5, divide this side by 5, the 5's gone, and you would have 4x plus 2, x minus 1, okay? So it's up to you. If it looks like it's easy to just divide out the 5 because it's already factored, it'll give you a whole number on this side. You can do that. That's not this equation. So here I would suggest distributing the 5. 3x plus 9 greater than or equal to 5x minus 5. Good. Again, I do not want a negative variable, so I'm going to subtract the 3x, subtract the 3x, bring down the 9 greater than or equal to 2x minus 5. Add the 5 to get the x alone, add the 5. 9 and 5 is 14. 14 is greater than or equal to 2x. Divide by 2. Divide by 2. 14 divided by 2 is 7. 7 is greater than or equal to x. I don't like reading it this way. I like it with the variable on the left, so you can flip it around. Right now it says x is less than or equal to 7. x is less than or equal to 7. 7 is greater than or equal to x. 7 is greater than or equal to x. Good. All right, and I think, oh no, 2 more. Oh no, we didn't even, too excited. We need to graph it. 7, x is less than or equal to 7. Less than or equal to means there will be a bracket. It's going to go in that direction. So if I think about from left to right, what am I looking at? I'm looking at from negative infinity to 7, including the 7. Good? Okay. Here we have 7 times the quantity x minus 2 plus x outside of the parentheses is greater than negative 4 times the quantity 5 minus x minus 12. So we're going to distribute the 7, distribute the negative 4, make sure you keep it a negative when you're distributing it. And then we're going to simplify on either side of the inequality symbol, and then we're going to start moving things across the inequality symbol. Good. All right. 7 times x is 7x. 7 times negative 2 is a negative 14 plus x is less than negative 4 times 5 is a negative 20. Negative 4 times a negative x is a positive 4x. And then there was just a negative 12, right? Let's combine the like terms. Positive 7x and x becomes 8x. The negative 14 stays the same. Negative 20 and negative 12 become well, I'll just put the 4x first. 4x, to put it in standard form, descending variables. 4x minus 32. Again, I like to keep my x's positive, so I'm going to subtract the 4x from both sides. Eight minus 4 is 4x. Minus 14 is greater than negative 32. Add the 14. Negative 32 plus 14 is negative 18. So we have 4x is greater than negative 18. Divide by 4. Divide by 4. Negative 18 divided by 4. It's a decimal, but it's also negative 9 halves because you can divide both 18 and 4 by 2. Negative 18 divided by 4. Negative 18 divided by 2 is a negative 9. And then 4 divided by 2 is a 2, right? So the simplest form of negative 18 fourths is negative 9 halves. X is greater than negative 9 halves. We saw in our calculator that negative 9 halves is negative 4.5. So between negative 4 and negative 5, you would graph that x is greater than negative 9 halves. It goes from negative 9 halves to infinity. Good? All right. Example 8 is an opportunity to apply what we are learning. So you are having a catered event. You can spend at most $1,200. The setup fee is $250 plus $15 per person. Per person means multiply, right? Find the greatest number of people that can be invited and stay within your budget. So my budget is $1,200. Should I say that I want $1,200 to be, okay, so here's my event, right? My event is E. E is less than 1,200. E is greater than 1,200. E is less than or equal to 1,200. E is greater than or equal to 1,200, right? I cannot spend more than $1,200. Yeah. So 1,200 is greater than or equal to the 250 they're going to charge me to come, plus each person is going to cost $15. Good? So tell the story again. I can spend $1,200. My setup fee is $250 plus $15 per person. How many people can I invite? That looks like it follows, like my inequality looks like it follows the story they told. Okay? Now just solve for P. Subtract 250. Subtract 250. 1,200 minus 250. 950 is greater than or equal to 15 times P. All right, so I have $950 to spend on people. How many people can I invite if each person costs $15? Let's be 63 1/3 people. 63.3 people. So the greatest number of people is not 64, it's 63 people. It has to be, yeah, 63.3 is greater than or equal to P. So P is less than or equal to 63.3. You can't invite 0.3 people. So we are going to invite exactly or less than 63 people and hope that they all come. All right, guys, that is all for introducing inequalities. Please email if you have any questions and have a good rest of your day.